So what we're looking at here is the two-part assembly which we learn how to make in the first session. And what I wanted to start with this week was to kind of extend it a little bit further with a few more elements of Solidworks, but also to talk about how to put the dimensions and constraints on to make things behave the way that you would like, particularly with reference to the kind of practical considerations when you come to make something and discover things like your material tolerances are not. Everything in CAD is kind of a perfect view of the world, and then the reality, when you actually try and make something, you find that your 3mm thick acrylic is not actually 3mm, but is got a kind of tolerance associated with it. And I'm going to go over some of the tips and tricks that I use to avoid having to do a lot of reworking when I want to make adjustments to the model. So just a very quick recap, we've got these two parts. So I'm looking at the assembly which we created last time. And if I click on one of these parts, then the kind of dialogue that pops up next to it, the first item in there is open, and that's a quick way to open the part to get to the individual part which was in that assembly. So we had two quite simple parts. One of them, we started off with a rectangle, so you can drag the kind of history bar up on the left to see the kind of steps that went into making up the shape. So we started off with a boss extrude to make a rectangular lump of acrylic. Then we added a tab as another boss extrude, and then we use a linear pattern to duplicate that. And if I select any of these items, then the dimension of that feature gets highlighted on the CAD model. So you can see that that linear pattern was a 50mm separation, and that my tab was 18mm wide, 5mm in from the end, and it was 3mm deep. And then our other part was a rectangle with a cut extrude to make a hole in it. And then we used a linear pattern to duplicate that hole. So I'm just going to make a few more changes to kind of essentially create a box. So in my my base plate, which has the holes in, I want to duplicate the holes across onto the other side. And I'm going to do that by actually mirroring the feature rather than drawing more holes. And in order to do that, I need to say what plane I'm going to mirror about. So I'm going to introduce reference geometry, which is this menu here. Reference geometry are aspects of your model which don't exist in the real world, but they're references for defining other features. So we've already got some reference planes. They're hidden by default. But if I click on the eye here, I can click on the show primary planes, and you can see they've now appeared. We've got our top plane, our front plane, and our right plane. By default, they tend to be hidden because once you've started creating your model, they get in the way. But what I want is a plane for mirroring that goes right down the middle of my part. So I'm going to click on reference geometry plane. Now there's lots and lots of different ways you can define a plane, but in this case, I'm going to make it go right down the middle by selecting the center lines of some edges. So as I learned last week, I think Melanie taught me this trick. If you right click on an edge, then actually select midpoint appears on the menu, which is a little bit easier than hovering and trying to find. If you kind of get just the right point, the midpoint appears. But if you just right click on the edge, you can do select midpoint. So I've selected two edge midpoints. I need 3 to define my plane, so I'm going to also pick that one there. And you can see now on the left, my plane is fully defined. So it's got all the information it needs to define a plane. And because I've selected the midpoints, I know it's halfway between the kind of 2 edges automatically.
There are 2 more ways to do this, just for completeness sake. If you select both the left and the right plane, like the narrow edges, you can use a midplane relation, define the plane that way. or you can select one of the side surfaces and one dot on midpoint, and that'll also define the plane.
That's an interesting one. So let's try that. I'll clear my 3 references. So you're saying that if I select that edge and that edge, then I get a fully defined midplane halfway between the two?
Yes.
Which is nice because they're a lot easier to click on than those midpoints.
Exactly. And the other one is selecting one of these surfaces and one midpoint. We'll do the same.
All right, and then it translates the plane through the midpoint. Excellent. It's always nice to learn something new in these sessions. So I'm going to go for the midplane because I like that because it's easiest to click. So I've got a fully defined plane. Now, all of these features that appear as you kind of build up your model have very generic names, and I find it really helps as your model gets more complicated to actually give them more meaningful names. So I'm going to actually change the name of that one to midplane, because then in the tree I know what that is straight away. And now I'm going to do a mirror feature. Now I've already got the plane selected, which means when I select mirror on the toolbar, it will use that plane as the mirror plane automatically. If you haven't got the item selected, then when you select mirror, you have to first of all select what plane you want to mirror about. So with that box highlighted, I can just click on the plane and it fills it in. And then the other thing we need to do is say, what is it we actually want to mirror? Now you can select the features directly, but it's also, remember, you can open up this tree here. And if I select the linear pattern, it will automatically pick up both holes because the linear pattern includes the original hole plus the copy. So now I've got 4 holes in my part, and I know they're equally spaced around the middle. What I want to look at now are the actual dimensions, and you can use the evaluate toolbar to get the measure tool to actually measure dimensions on your sketch. So if I select 2 edges, it will tell me the distance they are apart as well as how long the edges are. So I've got 2 edges that are 44 millimeters apart. Now, if I'm trying to design something where I actually want to fit something in the middle between these two, which is 45 millimeters wide, then we need to think about how did that 44 millimeters come about in my defining of the model. If we go back to our original boss extrude, you can see that we defined it to have a width and a length. And then when we put our cut to define the hole, we decided we wanted it 5 millimeters from the edges, and we wanted it to be 3 millimeters wide and 18 long. So effectively, the gap between our 2 parts is now made up by taking the 60 dimension here and subtracting the 5 millimeter margin and the 3 millimeter width of the hole times 2, because there's 5 and 3 taken off there as well. So that's 60 minus 16, which gives us the 44 millimeters. But because I've defined the dimensions that way, it's a bit fiddly if I want to go back and change that to get my 45 millimeter gap, because what I'd have to work out is, well, my slot's 3 wide, so I've got 6 millimeters worth of slot to take off. That taken off my 60 gives me 54, and I want 45, so that gives me 9 surplus, which means that I want to make my cut 4.5. So I double click on it, I can type 4.5 millimeters. And now if I measure the distance between my slots, oh, and I haven't gone and rebuilt. So see the traffic light icon here, that's to do a rebuild. And you can actually see that it's showing that icon as well against this cut extrude. So that shows I've made a change to the model, but it hasn't recalculated how that propagates through the whole part. So I need to click rebuild. And now when I go and measure, it should. Oh, I need to. My measure toolbar is appearing on my other screen, so you won't have seen it. This little toolbar pops up. If you click away when you're using the measure tool and click on something else, then when you come back in, you're not always in measure mode. If you don't get a green highlight when you click on something like that, you need to just go and select the toolbar again. So now you can see we're 45 millimeters apart. So I can make that adjustment, but it is a bit fiddly. If that was really my critical dimension, then it would have made more sense for me to actually go and measure the distance of this slot from the midplane rather than from the edge, because then I could have said that, because what happens now is, let's say I decide that actually I want my material to be slightly thicker. So if I go and make my material 62 millimeters wide, what's happened now is that my slots are now 47 millimeters apart, because I've defined them with respect to the edge rather than from the middle. So there's no right or wrong way to define your constraints, but you do need to think about how you want your part to behave if you make adjustments later. And so if the critical dimension is to fit something in between these slots, then a better way of defining the cut would be to measure from the midplane to the edge of the cut. However, my midplane is currently defined after my cut, so I can't do that unless I change the order of the things in the tree. And this is a kind of an area where things can get very complicated, because certain things depend on certain other things. So for example, if I try and move the mirror feature, you see the icon has changed to a kind of no entry. I can't move it above the midplane. The reason for that is that the mirror actually references the midplane in order to do the mirroring. So it can't go above it. In this case, my midplane was defined only in terms of the two faces of my original solid. So I should be able to move it up all the way up to the boss extrude. I can't move it above it because it's a reference of something that references that boss extrude, but I can move it to there. So now my midplane is defined before my cut extrude. I can go back in and make some changes to the dimensions. Now the dimensions are actually on the sketch. So I've opened up the little arrow next to the cut extrude, select the sketch, and then select edit sketch on the little pop-up toolbar. Now I can go in and delete this dimension here, saying that it's 4.5 millimeters from the edge, and instead put a dimension between the midplane and that edge. And if I want them to be 45 millimeters apart, then I want these to be 22.5. My sketch is fully defined again, so I can exit dimension, exit sketch, and we're back to our shape with our expected distance, 45 millimeters between the slots. But now note that if I go and make my solid wider, my slots stay 45 millimeters apart. So they're no longer 5 millimeters from the edge. They're instead 45 millimeters apart around the center line. So the way the whole shape behaves when I change dimensions differs depending on where I've defined those constraints.
A couple of things that might be worth mentioning just for the listeners here. There is a discussion amongst Solidworks users on whether all sketches should be fully defined or not. And actually, you don't have to fully define them. It is a choice. It just makes sense in most aspects. The other one is, and this is something that really threw me for a loop when I started with SolidWorks, is that if you change the width of this piece to be less than 45, your features following that will explode. They'll all suddenly be marked red, and it's a skill that you'll only learn over time to find out what actually causes the blow up, especially when you don't get the blow up until you rebuild. So rebuild often.
Yeah, so if I make my sketch smaller than 45 wide, then my cut extrude. Now in this case, it's actually saying that it can't rebuild straight away, which is nice. I can say continue and ignore the error. And now you can see it's actually showing that my cut extrude doesn't intersect the model. In other words, my sketch is outside of anything solid. And I can use the undo feature to go back. If in doubt, undo can be your friend. Thank you, Melanie.
Again, there's only so many undo steps.
Yeah. Okay, we'll go back to our side plate now. And I'm going to do the same thing with the side plate. I'm going to mirror my my slots. So now this time, because I know that I want my mid-plane, in fact, no, it doesn't matter because my slots are always going to be on the edge of my part. You can't define them anywhere else in this case. So I'm just going to add a midplane. Now, because I've already got all of these features on here, if I actually select that plane and that plane, my midplane appears where we want, but I have a feeling I won't be able to. No, in this case, I can move it up. The reason I was wondering whether it may not is that this face here is actually not one continuous face anymore because I've got that other feature. And sometimes when you click on a feature, if I clicked on one of these planes, for example, then as well as my midplane no longer appearing in the middle because it's now halfway between the tip of that tab and that edge.
There's one more thing.
I now can't move it up to the top because it depends on this second feature.
There is, I think the time has come to introduce rollback.
Introduce what, sorry?
Rollback.
Rollback.
If you roll back to before the extrusions, you'll have the original face. You can place your midplane, then roll the extrusions forward and mirror them.
Exactly, yeah. Let me, so I'm just going to undo until before I put that plane on there. There we go. So if I want to actually define that plane before I define those other features, I can use the history, the rollback bar, to go back to that point in the sketch, in the creation of the shape. I can now define my plane on that part, and then I can roll forwards, and it will continue to build the other features. Now, sometimes you run into problems because if you define something that actually changes the shape, then your other features may not build properly again. A great example of that is fillets. So if I go back, so I'm not sure if it really works on this plate. Fillets, if you remember, are where you apply curves to features on your part. And that feature depends on a feature further up the sketch. Let me.
There really aren't enough features in this sketch to demonstrate that properly. You'd have to create some extra features in order to show it.
Yeah, let me extend one of those tabs. I'm going to do a boss extrude, and I'm going to select the whole face, convert it into a sketch entity, So I've got a fully defined sketch, which is basically the perimeter of that face. So I clicked Convert Entities, selected a face, and I've instantly got a sketch that represents whatever shape that face has. And then I'm going to add another 10 millimeters to it. So I've now got a longer tab. Now, if I go and roll back, actually, what I want to do is put the fillet on and then roll back. So I'm going to put a 3 millimeter fillet on that corner. Now, if I roll back to before I created that fillet, and now I do that boss extrude. So I select Convert Entity, select the face. I've instantly got a fully defined sketch for that face. And now I can extend it. Now, when I go to roll forwards, notice that the corner that I put the fillet on no longer exists in the shape. So when I select fillet, my fillet is blown up. And if I go in to edit the fillet, you'll see that the edge that the fillet was on is missing. So I need to repair that or just delete the feature. Now the quick repair would be to just go and select the thing I do want the fillet on now. My sketch is repaired. But that's just a kind of small taste of some of the kind of pain you run into when you make changes during a rollback. I'm just going to take this back to before we did all of that. Because what we actually wanted to do here was to mirror our pattern. So I'm going to select mirror, select the plane, and now you notice that if I select the original boss extrude, it just does the boss extrude. But if I select the linear pattern, then it does both of them. So now if I go back to our original assembly, now I may need to do a rebuild, but in this case, it looks like it's picked up all the features, but it's always a good idea to hit the rebuild. What I can do now is add more copies of these. Now there's two ways I can do that. I could go back and insert another copy of my component. Now I found what I suspect is a minor bug in Solidworks. When I've selected this component, it's not giving me the option to kind of do any sort of rotation of it. Unless I use the tab key, which gives me some kind of rotation. But if I come out of that and try again, I'm not sure what it is that triggers it.
They actually fixed this in 2021.
Did they? Yeah, there's some occasions where when I put the part, if I go and do another one now, let's see if it, no, it's not playing ball. There's some circumstances where you get a little rotation menu appears down the bottom here, and you can actually choose the rotation before you place the part. But I don't know what it is which causes it. Anyway, let's not get hung up on that. I've inserted another copy of each of my parts, and I can orientate them by putting the mates on. So I'm going to say that I want this face to be adjacent to this face. You can see it's already rotated into the correct orientation. And then I want to make this face line up with the inside of that slot. and I want this edge to line up with this edge. So that's got it in the right place, but
it's the wrong way around.
yeah, notice that my slots don't line up, because what I did was I aligned the edges, which in reality is not how your part holds together. Your part holds together by the slots. So I'm going to...
I was going to say, there's an easier way to get the part in the right orientation from the get-go. Just control drag it in the assembly, because you'll just pull a copy off.
Control drag the existing part to duplicate it.
Exactly.
Yeah.
And it'll come off in the same orientation.
Now, if I had gone and actually, that's not letting me select what I want to now. If I had said I want the two edges of the slot, notice it's aligned them the opposite way around to what I want, but I can come over to the mate alignment and flip the mate. So now my slots are lined up, and it's telling me it's reversed a couple of other mate alignments as well to match. So now it's fully locked in place, but notice that it, because I put it in back to front, it's overhanging the edge. So what Melanie was suggesting is that rather than inserting the part by inserting a brand new one, instead just select it and hit delete, and it's asking, do I want it? It's going to delete all the mates because the part's disappearing. What I could have done is hold Control and drag the copy of the part. And then it'll be the right way around. Now I still need to go and define all the mates to put it in position. There's another way I could have done this, and that is, instead of inserting a separate part, is I could have actually done either a linear copy, or I could have done a mirror. So if I select linear component pattern and say I want to move in the direction of that face, and I want to move that component, and I want two of them, and I know that my slots are 45 millimeters apart, so I can put in 45.
+45 1 thickness.
Yeah, because it's
Actually,
45 between the inside edges of my slot, so I need to include the thickness of a slot. There we go. And I'm going to do the same with this. I'm going to delete this part, and instead I'm going to do a linear component pattern. So I select the face that I want as the direction to move it in, the component I want to pattern, and then I can't remember what height these were, but we can either do it by trial and error. Looks like it was about 33. There we go. So I must have made it 30 millimeters, and I've got a 3 millimeter slot. So we've got a nice box, which in the theoretical world all looks great. So we go to laser cut it. Now, I can't remember if we created a drawing last time. I have a feeling we created a drawing for my other parts, but we'll have a quick look. Yeah, we created a drawing from the other thing we were messing about with last time. So let's create a new drawing. So I could do make drawing from assembly, but I don't want the assembly in the drawing. I want the parts in the drawing. So I'm just going to say create new drawing. I'm going to just do an A4 sheet. I don't need all of this kind of legend, so I untick sheet format. I'll just get a blank A4 sheet. And then over here on the parts menu, I can pick one of my parts, drag in the top view of that part, and click the tick, and then I can select my other part. The parts appear here if they're open, if the documents are actually open in SolidWorks right now. If they're not, then you can use the ... menu to go and browse for files on disk. So we'll also grab the base plate and drag one of them in. And there we've got essentially the drawing that I want to put into the laser cutter to laser cut those two parts out. The problems come when you realize that your 3mm acrylic sheet is actually cast acrylic. And the way they make it is they basically pour a load of liquid acrylic onto a big flat bed so that it kind of pools up to 3mm thick. And then they let it cool until it sets into a nice sheet of acrylic. But there's surface tension on the surface of that liquid acrylic. And so the edges of the sheet tend to be thicker than the middle because it kind of bows down in the middle. So what you actually find is, depending on where in the master sheet that was cast your piece of acrylic has been cut from. So if you buy, say, an A3 sheet of acrylic from a supplier, it's probably been laser cut out of a much bigger cast sheet that was made in the factory. If it was from near the edge of that sheet, it might be up to 3.3mm thick. And if it was from the middle, it might be as thin as 2.8. So we've got these slots that are 3mm wide to take the width of our material. And then we find that our piece of acrylic is 3.2mm wide. So after I've laser cut it, I can't actually slot it in because my slots are too narrow, because my material is slightly thicker. So kind of lesson one, which I learned the hard way, is measure the thickness of your piece of acrylic that you're going to laser cut before you cut all your parts out, because otherwise your tab and slot parts won't necessarily go together, or they'll be quite loose, depending on whether you've got a thick or a thin sample of acrylic. What we want to do is go back and fix that problem. And this is where we realize that we've made all sorts of mistakes in how we've defined our part. So let's first of all think about, where does our thickness of our material occur in our CAD drawing? So the first place it occurred was our Boss extrude, where we said we wanted a 3mm thick piece of material. It then occurred again when we did the sketch for our slot, and we said that we wanted the slot to be 3mm wide. And then it occurred another time in our side plate, where we said that we wanted our tab to be 3mm deep so that it would just fit flush with the surface of our base plate. So there's three places where I've defined 3mm in my parts. If we just start with the base plate, so that things don't get too complicated. Sorry, was there a question?
It's 4 places. The side plate also has a thickness.
Thank you, yes. So the side plate was also made from 3mm thick acrylic. So I've defined 3mm in 4 different places in this simple assembly. I've defined it twice just in this one part. And there's a way to save you having to, if I wanted to make my acrylic 3.2mm thick, there's a way to do that by using the equations feature. So on the tools menu, you can open up equations and you get a dialog box like this, and you can define global variables. So I'm going to create one called thickness, and I'm going to say it's 3mm. There is a syntax error. I don't quite know why it thinks there's a syntax error there.
Doc,
Yeah.
the simplest way to add your equations is within the actual unit itself, where you label the size of your lines.
Yeah.
You can actually put your equation values within that bit. If you hit equals, then you get the option. You can actually type in names. So for example, see where you got at the top D1,
Yeah.
you can change that to thickness. I'm trying to hang on. I've used equations before.
Yeah. I've because this is defined in terms of the part, it only lets you change the name of the dimension within the part.
Yeah, but you can reference that dimension in other parts. There is a way of.
If I call that thickness and say it is 3 millimeters, I'm sure there's lots of different ways to do this, which is why these sessions are great for me, because I learn from.
Yeah, I've used the equations on a few to make. I think I was making nuts and bolts. I actually designed my own and I print them off. So I was using the equations to make them all match.
Yeah, I'm going to do a whole session on nuts and bolts design in another one of these clubs, because that's something I've been playing with spreadsheets as well.
I'm just trying to remember how I actually incorporated.
Yeah. So what we've done here now is we've renamed that dimension to be called thickness rather than D1. But I'm not sure how I then, when I come to define this, whether I can reference it.
Just type it in. Thickness at. Then I think it's sketch 1.
Yes.
I think the variables there look is more convenient and cleaner than that.
Yeah, that's. I mean, there's definitely something in the way that's done, but it's not going to enable me to follow on with what I want to show using equations. So I'm going to go back to equations and explore the dimensions aspect another time. I'm just not quite sure why it was.
Yeah, I'm just going to
happy with.
Yeah, I'm going to quickly look up my equations and find out how I went about them. Then I should be able to give you a few pointers if I can find them. So I will be back in a moment.
Yeah, it would be great to have a discussion after the hour. Okay, that didn't take, so. Why does it think that is invalid? It's still not happy with it. No, I'm still not sure why that's not happy. I'm going to open up a part where I've got this working. Let's make something simple. can't see anything that I've done differently in this part, other than that they're linked to a file, but we've not got there yet.
Did you fill in the evaluates too, or did Solidworks do that?
We just went equations. Oh, I didn't mean to do that. I think it was a bug. I don't know quite what's happened there, but it's taken it now. I think. Tools. Equations. Yeah, whatever was upsetting it, it seems to have got over it now. So I've created an equation. I've created a global variable called thickness. Now I can go back into my part, and I can either just do it on the dimension by double clicking. And now instead of having 3 millimeters here, if I hit equals, global variables appears, and one of my global variables is thickness. So I can say that my thickness equals my thickness variable, and it's showing me with a globe that it's a global variable, and its actual value is 3 millimeters. But I can toggle between the variable name and the value. Now I can go into my sketch here, and I can do the same thing. Change that to my variable thickness. So at this point, my part looks exactly the same, except I can now go into equations. Still not happy.
Well, I tried it here just now, and I got the same thing, but when I did it again, I didn't put any spaces in the equation box, not between the equals and the 3, not between the 3 and the mm. That one worked.
It puts the space in for me.
Yes. Just take the space away, and then try to confirm. Now hit the check mark.
I don't understand why it's unhappy with this.
Let me just start fresh. Equations.
One of my equations have got the millimeters, it just says equals and the value.
I didn't push the green check mark. I hit enter. That worked. Did that pretty much instinctively.
I've got an error box on my other screen topping me. So now it's not happy because I've got wondering if thickness is some sort of reserved word.
It's not. It works for me.
It seems happier now. Now I've called it material thickness.
It actually doesn't work for me with thickness.
Yeah, I'm wondering if thickness has got some special internal meaning and that's what's upset it. Whereas material thickness is, it seems happy with. Now notice that it's created some equations using our global variable because we've actually assigned our global variable to those dimensions.
The problem might have been the fact that you labeled one of your dimensions thickness
Yeah,
and you labeled your global variable thickness.
yeah. I'm going to change that back to D1, which is what it was by default. Okay, so I should now be able to go into equations. Now it's all happy. And now I can say, actually, my material is 6 millimeters thick. Or let's go 5, because I can buy 5 millimeter acrylic. I click OK. I notice that both the thickness of my material and the width of my slots has adjusted itself. So that variable is being used in multiple places. So I can change my material thickness in one place, and that part is sorted out. But I still have the problem that my other part isn't using the equations. So if I go into equations there, it's blank. And I don't want to define thickness again, because if I do that, then I'll have 2 copies of it, 1 per part. So instead, if I go back to the original part and open up the equations dialog again, what I can do is say link to external file. So I tick that there. And it's saying, do I want to link to an existing file or create a new file? I'm going to create a new file. It's picked a name for me automatically. I'm going to leave everything ticked. I don't necessarily need everything in the file, but I found it doesn't do me any harm. Have it all in there and click link. And what that's done on my disk is it's created a file called equations. And that file has got my equations and my global variable defined in it. So now I'm going to close that and open it in Notepad++ because I get fed up otherwise with having to continually reload it. I'm going to go back to Solidworks and I'm going to go to my other part, open up equations, and I'm going to click import. And I'm going to select my equations file. And it's asking me, do I want to import everything? Now, technically, I don't care about those material thickness equations. All I care about is the global variable. So I could go and untick those. So I think it's that one. So I'm just going to import the material thickness, and I keep the link to file ticked. Now, you get this duplicate equations exist in the external file message, and I never, ever, ever click yes to this overwrite the file, because what it does is it wipes out all of your equations in the file. It's another place where this Notepad++ editor is a godsend, because if you did overwrite the file, when you come back into here, Notepad++ says, your file has changed. Do you want to update? Do you want to reload it? And you can say no, and then click save to save the content of the file back as it was. Always say no to this overwrite prompt. You can see it's brought in my material thickness. It's linked, so it's got this tick box and it's kind of grayed out, which means I can't edit it directly here. But it is now available for me to go and use in my part. So if I double click on a dimension, click equals, then I should see thickness, material thickness is in my global variables. So I can make my material, pick up that. And I can also make my tab. Now, sometimes when you get this quick edit box, clicking equals doesn't work. So if you don't get the global variables pick list, double click instead. and then you should be able to select it. And then it hasn't applied those. You can see I've got rebuild icons appearing in various places. So I'll hit rebuild, and you can see it's made my material thicker, my tabs thicker. And if I go to my assembly, I should hopefully rebuild that. And what we can see is that it's kind of worked, except it hasn't, because when I created this part, I did linear patterns to set the distance apart, and those linear pattern distances included my material thickness, but I haven't actually, I've typed in, it's not actually, that's the one I was looking for, the thickness was 30 millimeters plus the material thickness, which was 33, but it's not referencing the variable. This part is just got hard-coded numbers. So there's a little bit more work to do at this level. So what I'm going to do is I'm going to, first of all, there's some other dimensions that I really want. I want this length, the width of this part rather. So I'm going to go back to my side plate, and I've got my boss extrude. Now I could go and do this in the equations, but I actually find that once I've started one of these files, it's a lot easier to just go and type in the file. Give it a sensible name. Say my side plate width is 30 millimeters. So if I save the file and then come back here, now I can go into equations, click import again, say no, I don't want to overwrite the file, but I've brought in that new dimension. Otherwise I need to save it out to the file and link it, whereas if you always just enter it in the file, I find that workflow is easier for me to remember the order of things. What's it done now? It's brought in a equation from the file. This is why I probably don't want the equations in the file. So what I'm going to do is I'm going to delete that equation. I've unticked link equations to file. I'm going to go to my other part. Go to equations and unlink those equations. So none of my equations that are referencing specific parts of this part are in the file, are to be pulled in from the file. Now I can go back to my file and make my file just a file of global variables. So I've deleted those two equations there. So I've just got two global variables in my file. Now I should be able to rebuild. That's happy. Go to my side plate, rebuild. That's happy. Go to my assembly. Open up the equations box. Import my global variables. It keeps opening dialogues on my other monitor. I have to drag them across. So I've got my two global variables now in the assembly. So now I can go back to my linear pattern. And when it asked me how far did I want to move that copy of the part, if I hit equals, I can get global variables up and I can say I want it to be the side plate width plus the material thickness. So I can actually do the equation that adds those two parts in the dimension box. And now you see it's moved that plate up so that it matches the height. I've also got the same problem with my width. Remember my separation of the slots. So just to reinforce the workflow, we want one more global variable. I'll be descriptive, call it box inside width equals, and we went for 45 millimeters. So I've saved the equations file. I can now go back to my base plate, do equations, import. Now it's kind of offering to import everything, and I find the easiest thing to do. This is the other gotcha. See that it's munged two things onto one line. The reason that's happened, I click cancel and go back, and this is again why Notepad++ is the better editor than just Windows Notepad. If I go to view, show symbol, end of line characters, notice that when SolidWorks created this file, it's created a mixture of character, that the Unix style carriage return line endings and the Windows style carriage return line feed endings. And
actually, Linux uses line feed only. Carriage return only is an old DOS variant that I've also found in some obscure protocols, but Unix uses line feed, and Windows uses carriage return line feed.
yeah, so for some reason when you let SolidWorks create this file and then you open it in an editor to edit it, the first time it makes a mess of this. So what you want to do is go to edit, end of line conversion, and select Unix. Pretty sure that's the one we want. Yeah, that's what I've used elsewhere. So once I've got the whole file with Unix line feeds, I can click save. And now when I do import, everything's happy. So I don't quite understand why it's kind of SolidWorks creates a mixture of carriage return and carriage return line feeds, or somehow SolidWorks seems to create the file with the carriage return endings, which the Windows editor doesn't support. But if you make everything line feed endings instead, the editor supports those, and SolidWorks is also happy. So I can click import. It's saying there's some duplicates, but they're global variables we just imported before. I'm going to say no to overwrite the file. And now you can see that I've got my 3 global variables. So I can now go to where we created our sketch. Now we defined essentially half of our width, but it's easier to think in terms of the width. So what I want is the box inside width divided by 2, because we're measuring from the slot to the midplane. So now you can see it's put a epsilon to indicate that this dimension is driven by an equation, as is the material width. And I should really probably do the same for our tab slots. I've said they're 18 millimeters long. And in my other part, I said that my tab was 18 millimeters wide. Of course, if you were laser cutting this, unless you're going to let the kerf reduce the width so that everything fits with a bit of slop, you probably want to make this slightly smaller than the width of the slot, because otherwise it will be very, very hard to push the 2 in, because they'll be exactly the same size. So if you want a 0.5 millimeter tolerance, then make your slot 0.5 millimeter longer. But what I would do is I would define this width length of this tab as a global variable, and then when I was defining the slot, I would define the length of the slot as the global variable plus 0.5 to give me 0.5 millimeter of extra.
At a point where I have more time, I can show you ways to do all this way easier. But now for the purpose of the viewers, I don't think that would be a good thing. It would be too distracting.
Yeah, I think it'd be great to kind of go over some of the things I've shown in another session and teach me some better ways to do things, because a lot of these techniques I've taught myself by trying to solve problems which I've encountered. We're kind of we've run for a full hour since we started the proper session, so I'm just going to put that last piece in, which is where I want to. Now, I haven't got that new dimension because in the assembly, I haven't linked I haven't sort of imported. Import, I don't want to overwrite. Now it should be accessible. So my inside box width plus my material thickness. So now everything lines up again, but I've also got the magic ability to go back to my file. I can turn off the symbol line end symbols now. I could change my material thickness. I remember we were thinking about our acrylic being 3 millimeters, but actually we discovered, let's say that our acrylic in this case was 3.2 millimeters thick. So if I just save that file, go back to my assembly and do a rebuild, by magic, everything still fits and it's adjusted by pulling in those changes to the equations. And I can do the same thing with any of those other dimensions. So I could say, oh, I've changed my mind. I actually want my box to be 50 millimeters wide, and I want my side plates to be 15 millimeters. Click save, come back here, hit rebuild. And something hasn't worked. So let's go and look at what's gone wrong there. So my side plate doesn't appear to have picked up, and it looks like I forgot to actually put the dimension into this piece. I know the dimensions there, I just hadn't applied it to my sketch. It was still hard coded to be 30 millimeters instead of side plate width. There we go, rebuild, that's shrunk, go back to the assembly. There we go.
And you have shrunk the box.
So that's probably enough for one session. I don't know about anyone else, but my head's starting to hurt now. We'll finish with just one more fun thing very quickly, because there's something I was going to include to kind of make things a bit nicer. We've decided that this is all going to be acrylic, so and I can do it at the part level or at the assembly level, but let's start with the parts. So my basic plate, you can see it's got a material item in the tree. If I right click and say edit material, then there's a whole library of materials, and we're going for acrylic, so it'll be in the plastics. There's a medium high impact acrylic, but there's also perspex, cast sheet. So if I pick that, click apply, you can see that I've now got a part that's actually kind of partly transparent. If I go back to my assembly, you can see that we can now see through my acrylic because it's clear. And I can actually also adjust the color. So if I click on this display manager, you can see it's got an appearance which is a clear plastic, but if I double click on that, then I can go and change the color. So let's say make that red acrylic. I can do the same thing on my side plate. I'm going to make that also cast perspex, and I'm going to change its color I'll make that one green. And now you can see that you can start to actually create things how they look in the real world, so to speak. And to show you just how powerful that is, I will open up one of my CAD designs that I've been working on recently, which is this robot. So it's saying that I've got a base plate in my robot that's not the same as the base plate I've currently got open in Solidworks, because I've called the parts base plate in two different projects. And that's going to upset it because it's used the base plate from the other project. So let me just go and close that base plate. Hopefully it will rebuild now. No, it's not happy. Ignore that. The point I wanted to make is that you can use this kind of material specification to define all of your parts with how they actually look in the real world and create much more realistic models than the kind of grey that things are by default.
That's where I fall over. All my items are grey, grey and grey. I could never get the hang of colouring everything in and making them look normal.
Yeah, I find it's easiest to do through the material to set the appearance and then just customize the color. But you can actually, in the appearance editor, go and put different colors on individual faces and kind of get a lot more clever about it.
Yeah, that's just not a part of SolidWorks that I've had a play with yet.
One last thing I'm going to share with you, but we won't go into the details today, is that a lot of things that you want on a project like this actually already exist, and there's no point in you trying to kind of build a massively detailed CAD model of them. For example, let me open up one of the components here. So this is an assembly where I've designed my foot leg robotics motor holder, but actually it was the motor which I wanted to show you. Oh, it wasn't. Let me just hide the. There we go. So you can see I've got a Pololu micro metal gear motor. I didn't design this in CAD. What I actually did in this case was I went to Pololu's website, found the part which I was going to put into my robot, and on the resources tab on their website, they have a 3D model in step format. So I downloaded the step file from there. Theirs came with, they had a step model with and without a bracket. I was designing my own bracket, so I just downloaded the step model for the, you can see they've got lots of different ones for their different gearboxes. So depending on whether you need the specific detail of which gears it has or just the general shape, doesn't matter whether you pick the wrong gearbox if you just want the general shape. And I loaded that into SolidWorks.
I wondered where you got all of those things from.
Yeah. So it's just a step model. I haven't had to do anything to kind of, because I don't need to edit it, I haven't had to do any conversion of it. I just included it directly in my assembly. The other place that is really worth knowing about is the community site GrabCAD. And GrabCAD is where people share their CAD models for the benefit of all. You need to create an account to download, but there's no cost involved. And you can then select the CAD library and go and search for, this is a great place to find CAD models to play with as well. You can see there's some really quite sophisticated stuff on here.
There's quite a few.
But there's also, if you wanted something like a metric hex screw.
Because I ordered takeaway, and that's past ready now. Bye.
So there you go. There's someone's designed some hex bolts, and in the search you can also choose by software. So a lot of people use step files, which are kind of compatible across CAD programs. So if in doubt, just download the step file. But if you're specifically looking for something that's already in native SolidWorks format, you can select SolidWorks in the search, and then it will filter the search results to just SolidWorks files. So that's another really useful resource for finding models, so that you don't have to build all the little parts in order to build up your assembly.
There's also quite a few odds and ends that are built into SolidWorks itself.
Yeah, there's a fantastic fastenings toolbox, but unfortunately it's not included in the student edition, which is what we're using with MakeSpace. So normally you would open up the design library, open up the toolbox, and it would have all the nuts, bolts, screws, and things that are kind of common fixings in there. But you have to have the engineering student edition or the professional edition of SolidWorks to get that.
So can I ask about the colors? Can you use a form of equations or parameterization to define your colors and then reuse them, or define complementary colors?
I don't know is the answer to that. I have only ever gone through, so there's appearances, and there's three aspects. Material is important if you want to do simulations. So we're not going to go into the kind of depths of simulations here. I'm just going to close this model because I've broken it by opening it with another part. Let's go back to our simple assembly. SolidWorks has some simulation capabilities, which mean that when you can do things like stress your part to see where its weak points are. So kind of how thick do I need to make my acrylic so it won't snap if I have a kilogram of force on the end of it, sort of thing. That's where the material level becomes important. So I've closed the base plate now. Let's open it up again. So when I selected material, I said it was Perspex because that has all sorts of physical properties about its strength and kind of fracture resistance and sort of physical properties. It also brings with it its appearance, but actually the appearance in terms of cosmetically how it's going to look in the CAD program is entirely independent, and you can play with that by opening up the appearance menu. So I could say, actually, I want to go for a low gloss blue plastic. I can drag that onto my part. And it didn't take, and I'm not quite sure why. If I double click, there we go. So now my part, instead of being clear acrylic, is now rendering as a low gloss blue plastic. Or I could pick a very high gloss plastic. Now you can't see much difference there because we're in a kind of grey light box type of environment. But you can actually go and choose to apply a different scene and say, let's go for a courtyard. And now it will apply kind of lighting effects based on that kind of background. So the kind of you notice how the kind of reflection changes because I've gone for a glossy finish. Whereas if I'd gone for the, I don't know, the textured blue, that hasn't given me the colors, it's just let me pick a texture. Let's go for a really knobbly texture. Then the way it responds to the light will be different. And if I go for low gloss, I don't get so much difference as I move it around because it's not very reflective. Whereas the high gloss changes depending on the angle. So you've got all of these appearance settings, and there's all sorts. So I can go for I don't know, stone, paving. So you can actually have kind of pattern textures, make everything look like it does in the real world. So wet concrete, brick paving. So I'll show you another CAD model, my current project, which I've just ordered the wood for today. I'm going to be building this in over the next few weeks. Is I'm designing a chicken coop and enclosure. So you can see here, I've actually put timber textures on my wood. I've gone for a slightly glossy kind of black for my bitumen roof sheets. I've got some hinges, some of which are at funny angles because something's gone wrong with my mirroring of my components, but they're brass. And I've got my metal mesh, which is welded steel. So I've used all those appearances to actually just put a bit of life into the model, and it helps you kind of navigate your way around. And this is a model where I've really heavily used those equations. So for example, the width of my chicken coop is controlled by a variable, and then the angles, if I open up one of these pieces of wood, the angle of the slope of this draft feature, you can see is 65.7 degrees. That is actually made up from the roof slope angle of my chicken coop. And if I open up the equations box, you can see that the roof slope is actually defined in my is actually defined as a global variable, which itself is a trigonometry equation based on the width of the coop and the height of the I'll get the box wide enough to show you the full. So the height of my roof support and the width of my piece of wood. So the height of the roof support is the vertical height of this part of the triangle. It's determining the angle there. So if I make my chicken coop taller or wider, then the angle of this draft on my piece of timber will change automatically. So the whole chicken coop, in theory, is editable to decide to kind of use thicker timber or make it slightly wider. So if I make any adjustments, my whole model still holds together and I don't have to redesign the whole thing.
Yeah, gives you the advantage if you can't get a certain sized piece of wood.
Exactly, yeah. Because I started designing this. This has also got some features which we've not looked at yet, such as making parts of assemblies have degrees of motion. So my gate is held on by its hinges and genuinely opens based on the hinges. And same applies to the doors. Oh, something's broken in my, let me try and rebuild. The more complexity you add to your CAD model, the more quirky sometimes things get. Yeah, for some reason it's
Not very happy, is it?
it's decided it's going to disintegrate. Sometimes when things get really kind of out of hand like this, the easiest thing to do is close Solidworks altogether and reopen it. Yeah, it's.
I think you'll find if you go into your list of mates at the bottom of your things, you'll probably find some of them, there you go, grayed out or even broken.
Yeah. I'm going to close Solidworks, not save, and reopen it. Let's see if that fixes it.
Yeah, I went through a spate version of SolidWorks I was using. What was it, 2018? I think I started. No, 2010 I started with. And on Windows XP, that had a few interesting quirks.
Yeah, I guess being a veteran going back that far, you've seen a lot of iterations of the software. Yeah, I'm not quite sure why it doesn't seem to like that degree of freedom. If I open the chicken coop instead, let me just. Because last time I checked, it was behaving nicely in the assembly of the chicken coop. It just seems to be misbehaving in the master assembly.
Do you have any books on SolidWorks?
I don't know.
Would you like a copy of the 2010 book?
I actually work for the parent company that owns SolidWorks, so I've kind of got access to the people who write the software.
Well, I have to admit, I got mine from a pirate site, the document, and that's where I started from. I started off with the book and then moved on to the software afterwards.
Yeah,
and I still
I found there's an absolute wealth of YouTube. I mean, this session is going to be on YouTube. Makespace will publish it on their CAD Club site. But there's a great array of yeah. For some reason, I've broken. I think it's because I've replaced this whole panel, and I've not made it free to move. Yeah, there we go. So I've defined my hinges and my doors so that I can actually kind of check the clearances, do all of my kind of nitty gritty design of the shapes of how I'm going to construct this so it sits nice and flush and draft proof, and design some removable trays for cleaning the floor. So you can kind of really do some quite clever stuff, none of which we're going to look at tonight because we've filled our hour and a half. So I'll just see, are there any final questions for this week before we wrap up?
Not for me, thank you.
I was going to say, there rolls by the dust storm.
Yeah, well, I'm happy to wrap it up there.
Yeah, by all means.
Thank you very much.
Thank you.
If anyone has burning questions before the next session, remember we do have the CAD Club Google group, which, just to remind people, is if you go to clubs.makespace.org, you can find the CAD Club link, and there's a link to join the Google group, and you can ask questions on there, and anyone who is in the Google group can answer. So it's a nice place for people to share knowledge. But I should notice questions that get posted there, and I can help you out if you've got any specific questions for the next session.